Structure of atom. Hello friends. I am Shubh Raj, and today we are going to learn about the structure of atom, one of the most exciting topics in class 11 chemistry. Understanding the atom is like discovering the building blocks of everything around us. Let's begin with a simple question. What is an atom? An atom is the smallest particle of an element that can exist independently and still keep the properties of that element. You can think of atoms like tiny Lego blocks that make up all the matter in the universe. Now, a long time ago, around 2500 years ago, a Greek philosopher named Democritus said that matter is made of very tiny particles called atoms. But back then, this was only an idea. There was no scientific proof. Fast forward to the early 19th century, when a scientist named John Dalton gave us the first scientific model of the atom. According to Dalton, atoms are tiny, solid, indivisible particles. He also said atoms of the same element are identical, and atoms of different elements are different. This theory was important because it explained how elements combine in fixed ratios to form compounds. But as science advanced, we discovered that atoms are not solid balls. In 1897, a scientist named J.J. Thomson found something amazing, a tiny particle called the electron inside the atom. Electrons have a negative charge. This discovery changed everything. Thomson suggested the plum pudding model, where electrons were like raisins in a positively charged pudding. Imagine a big ball of positive charge with little electrons scattered inside it. Then came an even more surprising experiment by Ernest Rutherford in 1911. He wanted to find out how the positive charge and electrons are arranged in an atom. So, he fired tiny positively charged particles called alpha particles at a thin gold foil. Most particles passed straight through the foil, but some bounced back at big angles. This was shocking. It meant the atom is mostly empty space, but has a tiny, dense, positively charged center called the nucleus. Rutherford's model showed that electrons move around this nucleus. But this raised some questions. If electrons are moving around the nucleus, why don't they just fall into it? And why do atoms emit light only at specific colors? A scientist named Niels Bohr answered these questions in 1913. He said electrons move in fixed paths or orbits around the nucleus, like planets around the sun. These orbits have specific energy levels, and electrons don't lose energy while moving in these orbits. When electrons jump from a higher orbit to a lower one, they release energy as light. This explained the bright lines we see in hydrogen's light spectrum. Bohr's model was a big success, but it only worked well for hydrogen, atoms with one electron. For atoms with more electrons, scientists developed a better and more complex model. This is the quantum mechanical model of the atom, which tells us that electrons don't move in fixed paths but are found in fuzzy regions called orbitals. These orbitals have different shapes, some look like spheres, others like dumbbells. To describe where an electron is and how it moves, scientists use 4 quantum numbers. Principal quantum number, n, it tells us the main energy level or shell of the electron. Think of it like the floors in a building. The higher the floor, the more energy the electron has. Azimuthal quantum number, L, this defines the shape of the orbital, like whether it's spherical or dumbbell shaped. Magnetic quantum number, M, it shows the orientation of the orbital in space, like which direction the dumbbell is pointing. Spin quantum number, S, electrons spin like tiny tops, and this number can be +1/2 or -1/2, showing the direction of spin. Why are these quantum numbers important? Because they help us understand the unique address of every electron in an atom. Before we finish, let's quickly review the main points. Atoms are tiny particles that make up everything. Dalton said atoms are solid and indivisible. Thomson discovered electrons inside atoms. Rutherford found the nucleus and showed atoms are mostly empty space. Bohr introduced fixed energy levels for electrons. Quantum mechanics gave us orbitals and quantum numbers to describe electron behavior. Understanding the structure of the atom helps us know why elements behave the way they do in chemical reactions. Thank you for watching. I hope you enjoyed learning about the atom. If you did, please like this video, share it with your friends, and subscribe to the channel for more fun chemistry lessons. If you want, comment below what topic I should explain next.